Hi, Fabio from Hopsworks here, and today we're going to be taking a look at how to retrieve data for real-time inference from the Hopsworks feature store. So in the past couple of videos, we have looked at how to create a feature view. A feature view, as we said, is a set of features that our model need to be able to be trained on or make predictions. Those features are joined from different feature groups in a point-in-time correct join. We use the feature view to create trained data and train our model. And now we want to use the same feature view and the same set of features to also make predictions, right? So the model in this specific example is a fraud detection model. It's dealing with transaction data coming in, and to be able to make a prediction on whether or not the transaction is fraudulent or not, it needs information about the profiles of the user, right? For instance, what's the age of the user, or like what's the recent activity of that specific user in terms of like credit card transactions and so on, right? So all these are features that are stored in the feature store, and the feature store, the Hopsworks feature store, provides the storage and API to be able to retrieve those features in a really low latency way to be able to do real-time predictions. And when I say low latency, I mean, you can see that later in the example, like single-digit millisecond latency, so that it's really fast to be able to push these features to the model and make a prediction, right? So in this video, we're going to be taking a look at how to use the Python API to be able to retrieve those features. We also have the equivalent for like a REST API equivalent to be able to retrieve features from the what we call online feature store. And we're going to be taking a look at that one in another video. Today we're going to be focusing on the Python API. So if we just quickly have a look at our project to see what's there, we look at, as we said, at the feature view itself, which is the fraud model. You can see here that I have a couple of things in my fraud model feature view. I have a couple of features from different feature groups. I can have a quick look at, for instance, the profiles feature group. All the feature groups are available online, so I can quickly have a look at the online data. You can see I have, for instance, the credit card number, the age of the user, the country where they reside, and all the things I have in my feature views are these model-dependent transformations. We discussed about those in the previous videos. I have one specific feature here, which is actually my label. When I'm retrieving data for inference, both real-time and batch, this label obviously is not going to be returned because that's what I'm trying to protect. So you will see later in the API, the API automatically is going to leave this one out, and so on. So if we look at the API itself, as always, we need to instantiate the project connection. So we need to import the Hopsworks library and do the login operation by specifying the information about what the deployment is, the project, the API key for authentication, and I get back the feature store object, right? So from the feature store object, I can retrieve my feature view, and that feature view is going to be used for retrieving the feature vector for real-time inference. Right, so in this example here, we are assuming that there is a payment processing system that needs to be making a request to the model to determine whether or not the transaction was fraudulent or not, right? So the payment processing system has a couple of different informations. For instance, it has information about the credit card during the operation, the category on which the credit card is being used for, and the amount of the transaction, for instance, right? So these are a couple of like what we call the input parameters that will need to be provided to our both model and also in this case the get feature vector operation to be able to retrieve them and make a prediction, right? So that's like our example here that we're working with. We said we retrieve the feature view operation, the feature view metadata from the feature store. I'm going to skip a little bit and come back on this one, this initialization of the survey in a second, and I'm going to just jump directly into the get feature vector method, right? So here we have a mix, or we call a mix of features that are retrieved from the feature store and that are available in the feature store. And these are features like the age of the user, the country where they reside, but also, as you said, the activity of the user in the past couple of minutes. And those are features computed by different feature pipelines, and they're available on the online feature store. But we also have features that are provided at runtime, right? So this, for instance, a good example is the amount of the transaction, right? So here we separate this in two different parameters that we provide to the getFeatureVector method. The first one is the entry parameter, right? So what the entry parameter requires is essentially the list of keys for which we want to look up the feature data in the online feature store. So for instance, in this specific example, all my feature groups are keyed by credit card number. So the profiles refer to a specific credit card number, the profile activities refer as well to a specific credit card number. And so what I need to provide here is basically say, okay, just a dictionary with just one entry, which is my key, the credit card number, right? What's going to happen is the getFeatureVector is going to go and going to look up the same credit card number across all my feature groups, and it's going to assemble the feature vector. To be able to assemble the final feature vector, though, we need to inject other features, which are what we call our pass features, right? So these are, as we said, the amount, the category, and a bunch of others that we need to add to the feature vectors, and they cannot be retrieved, and they are not available, cannot be retrieved from the online feature store, right? So what's going to happen here, and the final version of the getFeatureVector is basically, as we said, goes to the online feature store, retrieves data from the different feature groups based on the key, and then it basically injects and assembles the final vector based on the combination of data retrieved from the online feature store and data passed at runtime, such in this case, right? And it's going to make sure that the order is consistent. So it's going to make sure that, like, the position, let's say, of the amount feature is always the same. It's always, in this case, the first column. And it was the first column when we trained the model, and it's the first column right now when we make the inference. One additional thing it does, it applies automatically all these model-dependent transformations that we registered with our feature view, right? So if you see in this example, the category here, we provide it as a string, right? So it provides as cash withdrawal, right? But in my final feature vector that I have, the category is my second column. As we see here, the fraud label is not returned because, as we said, it's what we are trying to predict on. Category is my second column, and I have applied a label encoder on my transformation, as my transformation function, right? So here the value is 1. Well, what does it mean the value is 1? So what's going to happen here is that we're going to be, the Hopsworks API are going to be using the same statistics that were computed on the training data to apply the same transformation functions with the same statistics on the feature vector to be used for inference, right? And this is where this init serving actually is useful, because here we are saying, okay, return the feature vectors and apply the transformation functions with the statistics of the training dataset version 1. So this 1 right here represents the training dataset version that was used to train our model. And so that specific training dataset will have a specific set of statistics. And we're going to be using those statistics to compute the transformation functions, the model-dependent transformation functions, when we return a feature vector. As you can see here, we were mentioning before, the time it takes to retrieve that single feature vector is really fast. Here we're talking about, less than 2 milliseconds. So it's really suited for like real-time inference and really high performance essentially. So one other thing you can do in the Hopsworks API is actually return different types of data, right? So that it returns the feature vector with different types, right? So in the example above, we return it as just a Python list, but maybe we want to use a pandas data frame to be more comfortable when we pass it to the model itself, right? So what we have to do essentially, it's the same as before, but we add another parameter to our getFeatureVector call by providing the return type to be pandas, and this basically returning back our pandas data frame. Finally, what we can also do is we can also retrieve batches of data, and here we're not talking about large batches for like batch inference. That's a different API. But let's say I have like a high throughput service, and I want to batch a request, maybe do like small batches of like 10, 20 transactions, and be able to score them in a batch fashion from the model. I can also use the Hopsworks API to retrieve the same set of features for that same batch, essentially. So here we extended our input. So we have one transaction for groceries and one transaction which is cash withdrawal. And we also changed a little bit the way we retrieve the features. We are doing that using the getFeatureVectors API. Instead of passing a single dictionary when it comes to the entry and the pass features, here we are providing a list of dictionaries. It's basically saying, you can see here that, for instance, we are providing the first one being for the input 0 and the second one being for the input 1. We're retrieving that as pandas, and you can see here I have my pandas data frame with my 2 transactions and the features the model needs for making a prediction, those 2 transactions. And you can see here the category is 0 and 1, and the country is also being encoded using, as we said, the statistics for the specific training data set and so on. These return statistics, we're going to be looking at, just going to give you a quick preview now. We're going to be looking at the deployment of the model in another video. But what's going to happen ultimately is that you're going to take this feature vector and you're going to provide it. You can see here, this is our deployment on, let's say, kserve. So we need to define this predict object. And what's going to happen is that every time a request comes in, the kserve is going to invoke this predict method, right? And you can see that the final inference pipeline altogether. Here we are basically calling the same API to retrieve the feature vector using the same inputs that we receive from the endpoint that kserve set up, and then we are basically calling the model, and we're basically going to predict on the model itself to be able to make that prediction. So that's going to be our let's say end-to-end, end-to-end. It's going to be our inference pipeline complete with both the retrieving features from the online feature store and making prediction for the model. We're going to be looking at that one in another video, how to set up the kserve deployment and how to stop the endpoint and send a request to it. But this is just to give you an idea of how it looks together with the prediction itself as well. So that was it for the retrieving feature data for real-time inference. As I said, we have this as a Python API, but we also have as a REST API. We're going to be looking at another video how to do the same as we've done here by using the REST API.